Okay, this video is to go over how to raise a power to a power. So if you go to your foldable, it should be on page 51 or somewhere around in there if yours is a little bit different. And you're going to go to the third tab down where it says to raise a power to a power, right underneath dividing like bases. So to raise a power to a power, you're going to multiply the exponents, and you can see it right here that you have an example, 5 to the second power to the third power. So there's a power to a power because it's already 5 to the second. We're going to take it to the third. And the way that works is you actually multiply the exponents. So this would be a 5 to the second times 3, which is 5 to the sixth. Now, why that works? The reason why it works is because 5 to the second to the third would be 3 groups of 5 to the second, or 5 times 5. So I've got 5 times 5 times 5 times 5 times 5 times 5. And if you count all the 5s, it's 6. So it's 5 to the sixth power. If you can update that in your SBM, you could pause the video to be able to get that written down. And then we're going to go, not the next page because that's where we multiplied and divided like bases, but we're going to go the page after that. It should be about page 53 in your notebook, in your SBM. And we're going to do power to a power examples. Again, if you need to write this down, you can just pause the video. Okay, so again, you should turn 2 pages ahead, so the back of the examples for adding and or multiplying and dividing like bases, and then go ahead and label it as power to a power. And the examples we're going to use here are 1, 2, 3, 5, 6, 7, and 10, 12. But you can just label it 1 to 8 because there are 8 of them. Alright, so if you take a look at this number 1 here, I've got 6t to the fifth all in parentheses and then to the second power. What that actually means is that I'm going to take that second power and I'm going to apply it to everything in the parentheses. So just like when we distributed clear back when, you're basically going to distribute that second power to everything. So this is actually going to be 6 to the second and t to the fifth to the second. Okay, so like I said, this is actually 6 to the second times t to the fifth to the second. So you can either leave 6 to the second. If it says simplify like it does here, you should actually try to get your numbers in standard form and then your letters will be in exponential form. But if it says leave it in exponential form, then you can leave it in exponential form. So 6 to the second is 36. And then t to the fifth to the second is actually t to the 5 times 2. So you would actually change that, sorry, so this would be, so that would be 36, and then it would be t to the 10th. Okay, and so that's how you would do that one. If you take a look at number 2, I'm going to borrow this here. Grab that, put it over here. Okay, there we go. And so what this one here is actually 4 to the 4th, and then this is actually w to the 9th to the 4th. And so you would do 4 to the 4th, 4 caret 4 on your calculator, and that would be 256, I believe. And then this would be w, let's see, that would be w to the 36th power. So you could either have that 4 to the 4th, w to the 36th, or you could have 256 w to the 36th power. Okay, let's take a look at the next one here. Again, you should be doing this in your SBM. Make sure you're writing these down. Okay, so this one here is 12k to the 6th, and then in parentheses, to the 3rd. So this is actually going to be 12 to the 3rd, because we distribute that third power to everything in the parentheses. And then this is going to be k to the 6th to the 3rd. Whoops. All right, and then 12 to the 3rd power, you would do on your calculator, do 12 caret 3, which I believe is 1,728. And then this would be k to the 6 times 3, which is 18th. And again, you could, if it was exponential form, you would put 12 to the 3rd, k to the 18th, or if it was simplify like this says, then it'd be, you'd go ahead and figure out what 12 to the 3rd was. All right, go ahead and, whoops. Okay, go ahead and figure out what number 5 is. Go ahead and figure out what number 5 is. Pause the video and solve that. Remember, it's the 7th power to everything in there. So you're going to take the 4 to the 7th, the d to the 3rd to the 7th, and the e to the 5th to the 7th. Pause it and see what you end up with. Okay, so on number 5, you would have done 4 to the 7th power times d to the 3rd to the 7th. Oh, you can put a times sign in there also if you want to. It doesn't really matter. And so times e to the 5th to the 7th. And you would have gotten 16,384, d to the 21st, because 3 times 7 is 21, e to the 35th, because 5 times 7 is 35. Now go ahead and try number 6. And while you're at it, go ahead and try number 7. So pause the video, try number 6 and number 7, pause the video, and then come back to the video to check your answer. Okay, hopefully you completed number 6 and number 7. So on number 6, you would have done -4 in parentheses on your calculator, caret 4, and you would have gotten a positive 256. If you got a negative, it means you forgot the parentheses, and remember, you can't raise a negative to a power without those parentheses on your calculator. They're above the 8 and the 9. All right, and then you would have done r to the 6th to the 4th, and 6 times 4 is 24, so it's r to the 24th. And then s to the 15th to the 4th, you would have done 15 times 4, which is s to the 60th. And then for number 7, you would do 7 to the 2nd to the 2nd to the 2nd, which is 2 times 2 times 2, which in this case is 8. So it's 7 to the 8th. And that one is a pretty big number, but you can go ahead and do 7 caret 8 to get your actual standard form answer there. We're going to do numbers 10 and 12. So if you take a look at numbers 10 and 12, these are a little more complex because on number 10, they're actually multiplying powers to a power, and there's multiples here. So we need to kind of break this apart a little more. I'm going to break it apart for you so you can see it, and then you can try some on your own. Okay, when broken down, this is 4 to the 3rd power, x to the 2nd to the 3rd, and then that's multiplied by 3 to the 4th, x to the 6th to the 4th. And the reason why that's broken up that way is this 3rd power here just goes to the 4 and the x squared. And then this 4th power over here just goes to the 3 and the x to the 6. So you have to kind of break it all apart, and then you can simplify. So when we go to do that, we have 4 to the 3rd, which is 64. And then you have x to the 2nd to the 3rd. So you're going to do 2 times 3 there. So then you're going to get, sorry, I'm going to type this in here. 64. I'm going to get rid of this one. Okay, so x to the second to the third will actually be x to the 2 times 3. So you're going to get x to the 6th. And then we're going to go ahead and multiply that by, let's see, 3 to the 4th, which is 81. And then x to the 6th to the 4th, which is x to the 6 times 4, which is 24. But we're not done, because we can still actually combine like terms. So we're going to go ahead and combine our like terms. So this is 64. Oops, let's see, can I highlight that? So this is, oh no, it's not going to let me. So this is going to be 64 times 81. Okay, this is actually going to be the 64 times the 81, so we're going to combine like terms. So we're going to go ahead and I'm just going to write it in math type here so you can see it. So this is going to be 64 times 81 times x to the 6th times x to the 24th. So, just like before when we were working on multiplying powers with the same base, we're going to go ahead and deal with the 64 times the 81 because those are not powers with the same base. 64 times 81 is just multiplying. So you get 5,184, which I'm going to do that in math type. Sorry. So I'm going to insert this into my equation editor. And I'm going to get 5,184. And then we're multiplying powers with the same base, so we're actually going to add the exponents this time because it's x to the 6th times x to the 24th. So you're actually going to get x to the 30th there. Okay, do you see that? All right, that's how that works. If you take a look at number 12, you would just be doing 1/5 to the 2nd, w to the 5th to the 2nd, and x to the 3rd to the 2nd, just like we normally would do. 1/5 to the 2nd seems confusing, but you have the ABC button on your calculator. Go ahead and try this and see what you get, and pause the video, and then you can check the answer. Okay, so if you take a look at number 12, it'd be 1/5 to the 2nd, w to the 5th to the 2nd, and x to the 3rd to the 2nd. So you end up with 1/10 w to the 10th, x to the 6th, because you do 5 times 2 and 3 times 2 there. Hopefully this made sense. There is a practice sheet up in the top pink bin that you need to use next to practice these. You can always go back to the video and re-watch things and see how I did them. Hopefully this will help you and make sense. All right, thanks. Bye.